it's time to introduce our first speaker, one of the world's most respected technology analysts. I'm sure there are many of you here in this room who are subscribed to his weekly newsletter, read by 175,000 people across the globe. Uniquely skilled in identifying patterns and trends, there's no one better equipped to help us make sense of the frenzy of the past year and help us understand what might lie ahead. I am, of course, talking about Benedict Evans.
So thanks for that introduction. It's exactly the way I wrote it. I hope you now will understand what an enormously big deal I am and how lucky you are that I've come to talk to you. I was asked to explain everything that's going on in AI and do it in sort of 15 minutes and not talk too fast. I'll probably manage 2 of those, maybe 3. Everyone here actually does speak good English, so I can talk quite fast. Other places like America where it's a bit more difficult. I thought a good historical analogy historical reference to begin with might be a short story written in 1946 by a man called Will Jenkins, who used the pen name Murray Leinster, who was one of my grandfathers. And he wrote a story called A Logic Named Joe. He was a science fiction writer. He was the kind of science fiction writer who would write under 4 or 5 different names so that he could get multiple stories into the same magazine at the same time. He was very influential, which means that science fiction writers have heard of him, but there are no royalties anymore. And the story that he wrote, A Logic Named Joe, everybody in the world has a computer, which is called a logic at the time. These logics are all connected to a global computer network. They're all connected to databases, and you can do anything with them. You can book flights, you can read your bank balance, you can read the news, you can call up on-demand TV shows, you can consult encyclopedias. Basically, he's describing home computers and the internet, more or less, in 1946, which wasn't too bad for the time. My other grandfather, incidentally, was working in the intelligence services using computers to spy on the Russians, so it's kind of an interesting mix. Anyway, the point of this short story is that one of these logic ships with a manufacturing defect, and so it starts answering any question asked anywhere on the network as helpfully as possible, which means, what would be a good way to murder my wife without getting detected? And it says, well, here is an undetectable poison that I've just invented for you. Or what would be a good way of robbing a bank or making lots of money? He didn't actually describe Bitcoin, but there was some of it in that. And so there's sort of general panic, and the quote is, check your censorship circuits. The censorship is broken. And eventually they work out which of these computers it is, and they go and unplug it. And I read that story now, and it's actually a very good description of content moderation and everything that people worry about looking at AGI, which is not something I'm going to spend much time talking about. But I think it is kind of useful to think that we've been talking about AI for as long as we've had computers. In fact, since computer was a job title, a computer was somebody who sat at a desk with a pen and paper and did maths. They were computing. And every sort of 10 or 20 years, we've had the idea that these sort of machines might somehow reach some level of intelligence that's something like what we have. And so we used to call that artificial intelligence. And in the 60s, people said we would have artificial intelligence at the same level of people in a couple of years, and that didn't happen. And now people are saying it again, and we'll see. But the interesting thing about artificial intelligence is a quote from Larry Tesler in the early 70s, who said AI is whatever doesn't work yet. Because once it works, people say, well, that's not AI, that's just software. I flew here this morning from London, and I scanned my boarding pass, and I didn't say, I'm going to use a database now. It's just a computer, it's just a database, it's just software. And so AI has kind of gone through this process of anything that doesn't work yet is AI. Once it works, well, that's just image recognition, that's just speech recognition, that's just data retrieval, that's just information processing. And meanwhile, we got an awful lot of that. So we had databases in the 50s and 60s, we had information processing in the 60s and 70s and 80s, and now all of our banks and our taxes and our plane tickets are all processed through these computers, but we don't think of it as artificial intelligence. And as we went through the introduction of those technologies, it took a while to work out what they really meant. So we used terms like data banks or information processing. And what we first did with computers was we used them to replace paper records and to replace paper processing of documents. But over time, once you were able to move information in these ways, you could do things a lot more quickly and you could do different things. And so to begin with, what happens with every tool, you start by forcing the new tool to fit the way you already work, and then over time, you change the way you work to fit the tool. And so databases, for example, give us things like just-in-time supply chains, they give us containerization, they give us your supply chain moving to China or maybe back from China. But that wasn't all particularly obvious in 1950 or 1960. We had something similar that sort of struggled to work out what this is with the last wave of machine learning, indeed the last wave of AI, which started working sort of 10, 11 years ago when neural networks started winning the image recognition competition. Neural networks, incidentally, were one of those sort of dumb ideas from the 80s that had never worked, rather like VR, except suddenly they did start working. And I would show demos of image recognition, demos of early machine learning to big companies, and I would say, look, now you can recognize a picture of a cat, and people would say, well done. Like, why is this useful? That's very clever, but what is it that we do with that? And it took the industry collectively a couple of years to work out that this wasn't just image recognition, it generalized to a whole other class of problem. In fact, it really generalized to every other quote-unquote AI problem, which is to say it generalized to everything else that wasn't working, so speech, language, translation, and so on. And then we kind of realized, no, the right way to think about this is pattern recognition. And so a whole class of problem that pattern recognition that previously we couldn't automate, we were able to automate. And so it turned out that it wasn't cat pictures, or rather the thing that recognized cats, that underlying technology also gave you a much better way of doing fraud detection in credit card networks, or optimizing the layout of data centers, or better ways for planning power stations. And so it kind of generalized to what we now sort of think of as pattern recognition. And sort of the last 5, 6, 7 years, every new software company, or most new software companies, have really been saying, okay, we've identified this problem deep inside this industry, like banks or cement or shipping or aircraft or something, and we've worked out that we can turn this into a pattern recognition problem, we can turn it into a machine learning problem, and then we can build a company around that, and we can go out and solve that problem in 50 or 100 or 500 companies or inside some entire industry. To begin with, we call those AI companies. Now they're just software companies. If you're using machine learning to do pattern recognition, to look for strange emails when you're suing somebody and they've given you all of their emails, you don't think of that as AI anymore. That's just legal case management software or discovery management software. And so machine learning, that wave of machine learning, in the course of the last 10 years, has gone from being science fiction and magic to something that just works, and it's just software. And now if you pull out your phone and you type in a word, you will find that word on the cover of a book behind somebody in a photograph you took 20 years ago. And of course, that's just what software does. Of course it does that, even though 10 years ago that would have been science fiction. We're now, all of which is to say, we're now kind of at the beginning of another of these waves. We have a new, as we all know, kind of a new generation of machine learning around transformer models and large language models. That mean we have a new wave of things that we can automate, and there's a new wave of things that previously computers couldn't do that now we think we can get computers to do. And again, we have that question, okay, what is this and why is this interesting? And you have, again, the amazing demo. So you can, instead of recognizing cat pictures, you can make a cat picture. And you can ask for it to write you a song or to explain a picture or to write you a terrible undergraduate level essay or write some really, really great LinkedIn content for you. And it will do all of that, and this sort of looks like a kind of a great demo. But we're trying to work out, like, what is it conceptually that this is? How do we think about what it is that we have here so that we can work out what we can do with it? And the things that we saw last year, we saw the sort of the early obvious places that you can apply this. So we saw using LLMs to generate code, and we saw using LLMs to generate marketing material, which is kind of an interesting contrast, like on the one hand, the most logical and the most rational, and on the other hand, software developers. But both of those sort of worked very well, but we had a kind of struggle to work out, well, where else can we apply this? What do we do with this? And how do we think about it? Meanwhile, unlike, say, other places where you might have had that conversation, like, say, sort of smartphones or the iPhone or 5G, this remains a moving target. The state of the science keeps changing. We don't quite know what this is going to be capable of in 6 months or a year. There's a sort of small number of people who think that this might go all the way to what we sometimes call AGI, artificial general intelligence, which is kind of a word we had to create because AI had become meaningless, so now we call it AGI. But you don't have to believe that this is a very big deal. But the question is, well, what is it that we do with this? How do we think about what this is, what we could do with it, what we could build with it? There is, incidentally, an old English joke about a Frenchman who says that's all very well in practice, but does it work in theory? And so here we're sort of trying to work what theory we should have around this at the same time as working out what practice we should have about it. And at a very high level, I think you could kind of divide this into two kinds of questions. There are sort of inside tech questions and outside tech questions. And there's sort of a fairly small overlap between the two. So within the inside tech questions, there's sort of, well, open source models, proprietary models, what the fuck is going on at OpenAI, what's going on at Microsoft, is Mistral going to do okay, is the future multi-agentic self-referencing models, all sorts of kind of internal engineering questions as we've kind of proliferated from kind of the base concept to actually thousands of clever people actually trying to build software and build engineering out of it. Out of all of that, I think there's kind of a couple of things that are kind of questions or observations that matter outside of the tech industry and inside the tech industry. The first of them is that as I think everybody will know, large language models are really, really expensive to build and really, really expensive to run. I think most people in this room weren't born the last time the tech industry had marginal cost every time the user pressed OK. You kind of have to go back to mainframes in the 1970s to get that kind of economic kind of situation. But today it does. It actually costs money to press OK in an LLM, which is why OpenAI and everybody else were charging for it. And of course, part of the reason for that is that the way that OpenAI got that result with ChatGPT was to say, let's just throw an implausibly large amount of data into this and see if it works, and it did. But of course, then that kind of gets you two questions. One of them is, if you throw even more data in, will it get even better? And the other is, that's great, but how do we do this without spending $1 billion? And hopefully, how do we do it without having marginal cost? So we've got these kind of multiple pressures. On the one hand, let's drive the performance, the capability of the models forward. And how do we do that, especially given that we've kind of run out of data and we certainly don't have an order of magnitude more data, and that's not even thinking about who actually owns that data and what that means. And then the other side is, how do we get the models more efficient? How do we get them cheaper? How do we get them smaller? In particular, how do we get to the point that we could fit an LLM onto a smartphone, or certainly some kind of an LLM onto a smartphone? Because after all, last year, the hyperscalers, so that's Google, Microsoft, AWS, spent about $100 billion building data centers, but last year consumers globally spent about $400 billion buying smartphones, and those are not directly comparable numbers, but it's kind of a relevant comparison that effectively, as an app developer, you can get your compute onto the user's device and it doesn't cost you anything as long as you don't heat up the device too much. And so we've got these kind of pressures around how big the models are, how fast they are, how we trade off performance versus adding new capability. You've got the research model versus the production model versus the mobile model. And within that, of course, we also have open source. The old joke in Silicon Valley is that everybody is giving away somebody else's business model for free. And so clearly what we're seeing at the moment is Meta trying to give away Google and OpenAI and Microsoft's business model for free by open sourcing Llama, which is basically as good as GPT, as good as Gemini, but they decided to give the whole thing away. I think the underlying motivation for this really is, rather as Meta did a couple of years ago with something called Open Compute. Meta thinks that an LLM is basically commodity infrastructure, rather like a data center itself. And so they want it to be commodity and free and open source, and everybody to be working on it in order to be standardized and it to be as cheap as possible. And the differentiation is what you build on top of it, the product that you build on top. But make the LLM itself as freely and widely available as possible to everybody. And of course, there's a kind of a natural competitive pressure in the industry to push that towards everybody. Meanwhile, then you get all the kind of questions outside of technology. So if you're outside of technology, well, okay, you've got these models that do stuff. it's not quite clear how much better and how much faster they're going to keep on improving, or whether the rate of improvement is going to slow down. It's also not quite clear how we should think conceptually about what they should do. What we probably can do, say, is see, right now we're in the kind of the feeds and speeds phase of large language models. Everything is getting much faster and much cheaper, like orders of magnitude cheaper, really, really quickly. And meanwhile, we have to work out what it is that we can build with it. And I think I sort of alluded to earlier, we had these kind of two very early paths of adoption, which was coding and marketing. As we sort of sit outside the tech industry, there are kind of various ways that you can look at this. One of them is you can say we're thinking about bottom line innovation versus top line innovation. So bottom line innovation, what can I automate with this? And again, this is something that's kind of easy to see because you already know you're doing it. How do we automate our call center? How do we automate our marketing interns? How do we automate these processes that we already have? And that saves a couple of points of margin. Generally, in a competitive industry, when you save money, that drops straight through to lower prices to the consumer rather than being taken out as higher profits, incidentally. Meanwhile, you have a little bit of evolution from that where people are saying, well, what are things that we kind of theoretically could have done, but it would have been cost prohibitive? And now with an LLM, we're going to be able to do that. So this will give us this new component to be able to process information, ask new kinds of questions. So we'll be able to do things that we kind of wanted to do, but couldn't do before. And one of the ways that I think about those kind of processes, I've used this analogy talking about the last wave of machine learning, is that AI tends to give you infinite interns. You want somebody to look at every call coming into the call center and tell me if the customer's angry. You want to write 500 ideas for a slogan for this new brand. You want to give me 50 ideas for your latest piece of really exciting, differentiated content marketing to publish on LinkedIn. Well, you don't need an expert for that. You can probably get a 10 or 15-year-old to do that, except you couldn't automate it. You didn't have a million of them. Well, now you kind of do. And LLMs kind of give us another wave of that. But the other question is, well, what's the top line innovation? How is it that this comes and fundamentally changes the nature of your product or the nature of your business the way mobile did, or the internet did, or social did, or search, or cloud? And the answer to that is always kind of difficult, because it's always easy to say in hindsight why it was obvious that this thing was going to destroy you. I've sort of was reminded recently of the story in Herodotus that King Croesus of Lydia went to the oracle at Delphi and asked the oracle, if I invade Persia, what will happen? And the oracle said, if you invade Persia, you will destroy a great kingdom. And King Lydia didn't realize quite how ambiguous that answer was. King Croesus did not realize how ambiguous the answer was. And all of these kind of I could give you many frameworks for how you can think about whether an LLM will disrupt this industry or that industry. Are you more about information? Are you more about physical assets? Is an arbitrage opportunity? These are all kinds of analyses one could have done in 1996 about the internet. The problem is you'd have done that analysis and you said, well, travel agents are screwed, but hotels will be completely untouched, and so will taxis. And then, of course, somebody came along with a way that software actually could change what a hotel or taxi was. And so I'm kind of nervous about saying these are the fundamental changes that are going to come from this. What I think we can say is that we have a period of sort of 5 or 10 years in which this will go from being very cool and very exciting and very sexy and very interesting to being really, really boring. That's kind of how software has evolved. Apple will announce new iPhones this September. They could be made of diamonds and fly, and we would say, oh, another iPhone. And that's kind of the evolution of technology. Now, unless we believe, as I think Jeff Hinton may be suggesting later, that this is not going to follow a standard S-curve, that this technology is going to continue to scale indefinitely, or at least much further than we normally think, then this is going to turn into software. It will be a new wave of automation. It will be a new database, a new SQL, a new cloud, a new image recognition. And we'll have a whole kind of new class of pieces of software that will change everything. But we won't notice. They will just disappear inside what we're already doing. And they will be the thing that software just does. Because, of course, you can ask the computer to explain this to you, and it can explain it to you. The counter idea, I think, and then I will stop talking, is to think more about quite what it means that a computer can look at things and explain them and synthesize them to you. So what does it mean if you have an agent on your phone that sees everything you see, sees every image, everything you browse, every message, every order, everything in Instagram and Amazon, And then you can ask it questions like, where would I like to go on holiday? Or what restaurant would I like? As opposed to, hey, AI assistant, what are 5 restaurants near here? Which is always the demo people like to give. But when it can actually see everything you're doing and it can know about you, what could it synthesize out of that? That will be magic for a year or two, and then we will look at it and say, well, yeah, that's just what computers do. Of course it can do that. And then we will wait for the next thing that will change everything. With that, I will stop talking. Thank you.